Welcome to part 3 of taking the mystery out of pi. Now you might be thinking at this point that Mac is feeling pretty good about himself, right? I mean, he's got those 3 pieces of cheese in his belly, he's gotten around the circles, he's managed to stay away from Kruger so far. But no, Mac is really worried, and what I didn't tell you was that during his last run around that pie dish, the one that had a diameter of 3 feet, Mac just barely made it back. He felt Kruger's hot breath and his whiskers right on his tail. And Mac is suspecting that the distance around the circle is actually a bit more than 3 times the distance across the circle. And he suspects that that's why it was so close. It was just closer than he thought it should be. So Mac now wants precision. He wants to know what the exact distances are around these pie dishes. No more of this approximation business. No more of these squiggly lines. Mac wants more certainty in his life. So let's see if Mac is right about this. We have our classic situation here, right? Where he's 1 foot away from the cheese, but he has to run around in a circle. So far Mac hasn't gone any distance at all, 0 feet. He's still here inside the safety of his mouse hole. Now how far is 1 foot going to get him when he's running in this circle? Well, this is how far it's going to get him. And you'll notice he doesn't quite reach the cheese yet. And that makes sense, right? Because we said that this curved path is less efficient. He's got to run all the way down here, remember, and all the way back up. So 1 foot along this curved path will not get him to reach the cheese. Now when he goes 2 feet, he's got the cheese, but he's still got quite a way to go. And then on the 3rd foot, look at this. After 3 feet, Mac still has not reached safety. Mac is absolutely right here. He is not, the distance around this pie dish is actually more than 3 times the distance across the pie dish. Mac has to go a little bit of extra distance here, 3 plus some little fraction of a foot, to get back to safety. Do you know what the real distance is? Do you know what the actual exact distance is? If you said pi, you would be absolutely right. The distance around here, around this whole pie dish, is actually exactly equal to pi feet. Okay, so we know that this little circle has a diameter of 1 foot, and it has a circumference of pi feet, where pi is a number that's a little bit bigger than 3. But you know, it still begs the question, what the heck is pi? Well, a common approximation, it's not exact, but a common approximation for pi is 3.14. In fact, if you ask the average person on the street who remembers a little bit of their math, they'll tell you that pi is 3.14, or they may tell you instead that pi is 22 over 7. But it's not exactly equal to either of these numbers. Those are just common approximations. They're close to pi, but they're not exactly equal to pi. And you'll notice that 22 over 7 is equal to 3 1/7, which in turn, if we write it as a decimal, is 3.1429. So you can see that it's pretty close to that 3.14 number, but neither of these numbers is exactly equal to pi. So it begs the question, can we write pi exactly? Can we write it exactly as a decimal number? Can we write it exactly as a nice simple fraction of a whole number over a whole number? And the answer is no, we can't. And the reason we can't is that pi is irrational! Not like a crazy person is irrational, not like Kruger is irrational. In fact, you know what? The hint here is in the word itself. Look at that. We have the word ratio in there. And when we say that pi is irrational, we're simply saying that it cannot be expressed exactly. We can't write it exactly as a simple ratio. And by simple ratio, I mean a whole number divided by another whole number. Let me give you some examples of simple ratios. 22 over 7 is a simple ratio. It's close to pi, but again, it's not exactly equal to pi, because pi is irrational. 1/2 is a simple ratio. -5/8 is a simple ratio. But no simple ratio is equal to pi. And here's some more simple ratios. But the nice thing is that we can get as close to pi as we want by writing it to enough decimal places. So here, for example, is pi written to 500 decimal places. And you can see it starts off the way we expect, right, with the 3 and then the 3.14. But then after that it goes a little crazy. It just kind of goes off into all these weird numbers. No real pattern to them or anything. Now, if you had a lot of time on your hands, or you had a good memory, or you wanted to be the life of the next party, I guess what you could do is you could sit there and memorize the first 500 digits of pi. But you know what? In my mind, doing that wouldn't really make you any smarter, because it doesn't really get you any closer to understanding what pi really is, what it really means. And think about this. Suppose you did that, and you forgot what this digit was. Instead of a 2, you remembered a 5 there. Well, once you do that, all the other digits that you remember are pretty much useless. So in my mind, the important thing is to remember, not just remember, but to feel the math from the gut definition of pi. And that is that pi, it's a number, it's a little bigger than 3, and it tells us how many times further it is to go around a circle instead of across the circle. And that's going to be true of any size circle. Now, if you want to impress your teacher or something, you can always say, pi is the ratio of the circumference to the diameter of a circle. Okay, I promise not to use that voice again. Let's think about what this definition is actually saying. We spoke about ratios before, right? A ratio is just simply one number divided by another number. And when we say the ratio of the circumference to the diameter, what we mean is the circumference divided by the diameter. So this definition is telling us that pi is exactly equal to the circumference divided by the diameter, and this is going to be true of any circle. Right? Because let's think about it for a moment. We know that the circumference, the distance that Mac has to run around that circle, is a little more than 3 times bigger than the distance across the circle. So the distance around any circle is always a bit more than 3 times the distance across the circle. It's exactly equal to pi times the distance across the circle. And to keep it real, we'll say here that the circumference divided by the diameter, circumference is roughly 3.14 times bigger than the diameter. So Mac is now ready for his next challenge, and he's looking at that same 2-foot diameter pie dish that he was looking at before, but this time he wants to know the precise circumference of this new pie dish. Can you figure out what it is? Use the first example where we have the diameter of 1 foot, and try to figure out what the circumference is when we have a diameter that is 2 feet instead of 1 foot. Time to pause and ponder. Okay, so hopefully you noticed that the diameter has doubled from the first case, from 1 foot to 2 feet. And you remember what happens when one of the distances double, but we still maintain the same basic shape like we did with the Krugers before? That's right. All of the distances also double. So in this case, the circumference is also going to double from being exactly equal to pi feet to being exactly equal to double that, or 2 times pi, or 2 pi feet. Now another way to look at this is that every time we add 1 foot to the diameter, right, we're going from 1 foot to 2 feet, every time we add 1 foot to the diameter, we're going to add pi feet to the circumference. So our circumference is going to increase from pi to pi plus pi, or 2 pi feet. So overall, our lengths have doubled from the first case, all of our lengths. And whenever we add 1 foot to the diameter, we add exactly pi feet to the circumference. And this is true because the diameter and the circumference are, you guessed it, proportional to each other. And they are proportional with an exact proportionality constant of pi. And that is true because the circumference is exactly equal to the diameter times this number that's a little bit bigger than 3. It's equal to the diameter times pi. So now we're on to our third challenge. We're almost done the instruction here. This is the last case here. So Mac is now looking at a pie dish that has a diameter of 9 feet. Sorry, a diameter of 3 feet going across. I'm looking at that 9 over here. It's got a diameter of 3 feet, and he wants to know exactly what the circumference is. And I don't want you to just tell me what the circumference is. I want you to make a comparison with the first case, and I also want you to make a comparison with the second case. So it's time to pause and ponder. Okay, the most obvious thing that I notice is that the diameter is tripling from the first case, from 1 foot to 3 feet. And when the diameter triples, the circumference and everything else is going to triple right along with it. So the circumference in this case is going to triple from being pi feet to, you guessed it, 3 times pi or 3 pi feet. Now, when we compare it with the second case, the thing that I notice is that the one-way distance is increasing by 1 foot from 2 to 3 feet. And every time we add 1 foot to the one-way distance or to the diameter of a circle, the circumference is going to increase by pi feet. So in this case it increases from 2 pi to 3 times pi or 3 pi feet. So overall, our lengths are tripling when we compare to the first case, all of the lengths. And when we compare to the second case, when we add 1 foot to the diameter, we end up adding pi feet to the circumference. So congratulations, you've made it. You've made it through the third part of this pi video series. All the instruction is done. All that is left is the final fourth part, where I'm going to ask you to solve some problems about pi. To continue, select Taking the Mystery Out of Pi, Part 4 from the Math from the Gut video link.